group got a call from Apple, and if you're young right now, get your feet wet with a lot of things because it will change the way you see the world. Not all degrees are things that you're going to use directly to get your job.
Whom will you hire? Like, guys, today we have with us Dev sir, and this is the episode 2 from the robotic surgery episode. And he is the CTO at a new startup, at a new company with a new mindset and new people. And we are lucky to have him, and he has a lot of experience in the field of robotics, and hope he will share his good opinion on the robotics field and all the experience he has, and make sure that you utilize all his experience and learn new things. So let's get started with today's video. So Dev sir, how are you?
Hey, great, doing fine. Good to be here for part 2.
Yeah, it's my honor to have you again. Yes.
Thanks.
So, right. So, moving forward with the first question, actually, it will be like kind of about your college life. So, when you were in college, in your engineering time, or you were in your
Yeah.
graduation time. So, how you went through the engineering time, and what was the technical things you carried out?
Yeah. Okay. So I'm obviously a little bit older than some of your audience, but
Okay.
I started I started in college, and at the same time I worked. So I was just at the right time when you could still afford to pay cash for college, and so I was working as a assistant art director at a commercial print house, and so I was doing a lot of work with Macs, doing early pre-press, building artwork that goes straight to press. And then on the weekends, I was actually a systems administrator for a major accounting firm in the Midwest. And so I was operating old IBM 36, System 36, and AS400 mainframes. So it was a lot of fun. And so you had a lot of access to those technologies. And this was in the late 80s. And I got a phone call from a friend who had recently graduated from MIT. He started working for this startup that was doing something with something called the internet. And I knew about BBSs, and I had some access to email with crazy UUCP style addressing, so with exclamation points and all that kind of crazy stuff.
Right.
And he kept telling me, he's like, this is really cool. You got to come work for this. So I left college early and
Okay.
went to work for that company. We were actually the first commercial developer for internet software for Macs and Windows. And so
Okay.
that was actually kind of one of my first real big things. And I started working with basically internet protocol technology. In fact, there are a couple internet protocols that are no longer used that I was technical chair for in the International Telephony Union. So just had a lot of fun with that. And then I moved on to another group that was building what used to be called access concentrators. So if you remember, at one point you were dialing up to the internet with modems. And so this is where I started moving from software into more hardware oriented space. And you had a modem connected to your computer. What was it like at the ISP, right? And for most ISPs, they had a device that was about 2.5 feet tall, and it had 672 modems inside of it, and which is a whole which is called the DS3 for the amount of internet traffic coming in, which by today's standards is actually slower than most people's cable modems. A DS3 is about 54 megabits per second. So my $100 a month internet connection here in the US blows that away. But it's crazy to think about where we came from. And that had a whole bunch of slot cards and And we started to learn about like heat issues and power consumption. And when you're
Right.
literally selling millions of modems of a device like this to ISPs, you really start to think about like how much power is this consuming, how much rack space, and how much is the customer paying for the floor space taken up by that rack space. And so it really started to really shape some of my thinking in terms of like how you develop products and
Mm,
what are those factors, right? It's real easy when you're doing a student project. You just go on the
yeah,
shelf. I'm just trying to do this
really.
thing, right? And
Yes,
you don't
exactly.
always think about what all of the criteria are going to be in the field, right? And
Yeah,
I know there are exceptions to that, but it's that's not usually what's going to get your grade. So it's not the
exactly.
thing that's driving your thinking. And so that
Right.
really started to influence me. And that company got purchased by Lucent Bell Labs in the early 2000s or late 1999, I think it was. And that was an interesting change as well, because we went into a group that had massive research budgets. I mean, the transistor was invented at Lucent.
Okay.
They
Right.
owned most of the patents for Wi-Fi, which kind of came up a little while later because Steve Jobs had come back to Apple and he was trying to launch the new iMac with built-in wireless
Okay.
networking.
So that was at that time, like Jobs was
Yeah,
coming
yeah,
to Apple.
yeah. So
Okay.
that was like the early 2000s. Yeah. And and so that was the new iMac. And at the time, there wasn't any such thing as a hotspot. We were still at Lucent. There was a group called the Orinoco Group, and we had a little PCM CIA card that would do ad hoc wireless networks. Definitely not something that most people are doing
Yeah.
today. And our group got a call from Apple, and they wanted we needed a wireless modem. We hadn't even decided to call it a hotspot yet. And so that group at Lucent built the original Apple airport, the inside
Mm.
parts of it, and Apple designed the plastic that looked like a little spaceship. And again, you really started to get this idea. We had lots of discussions, really thinking about like what's the form factor and how are people really
Mm.
trying to make to make this work. What does it mean to replace Ethernet with wireless networking, and what kinds of things are going to affect it? So that was a really all of that experience really reinforced that notion that you've got to think about the potential users and potential customers as early as you possibly can, because it's going to affect the engineering decisions that you're ultimately going to
Mm.
make. Maybe not today, but if you can know that, okay, this is really where we want to go, at some point, I need to be
Right.
able to think about this form factor, or, that kind of issue. Um, and today, you see these kinds of issues. If you think back even just 10 years and you think about like the different kinds of electronic devices you had, so many of them had custom interfaces. Nokia had that little, notch device that would link onto your phones. Apple has the lightning adapter. They used to have the little 32 pin. And now people are starting to just go, enough of this. Can we just have, whether or not it's the best solution, having everybody be on USB-C at least makes it easier. And that's what
Right.
people want, right? And so we've
Mm.
already even seen that kind of progression. And you want to think about where's the ball moving, right?
Yeah.
Where ultimately can I go? Maybe I still have to make a certain decision today for practicality's sake, but where do I know I want to go? And having that understanding. And so keep rolling forward a few years. A friend of mine and I were approached by um, a group that was trying to commercialize some technology at a university in the Midwest. And it was
Okay.
sort of a handheld surgical robot. It was a navigated system
Mm-hmm.
that would provide guidance for a saw that you would use for cutting a bone when you're preparing a bone for a knee implant. And they wanted
Okay.
to completely attach the navigation system to the saw. And so this
Okay.
already like to create all of these issues of like, there's the technological feasibility. How do we do this
Right.
technologically? But there's also the how heavy is that saw already, and how much weight are we going to
Exactly.
add to it? And does
Right.
that, how long does the surgeon hold the saw, right? So all these questions started to pop out, and it was a really interesting interesting project just in terms of thinking about what the product looked like, as well as
Right.
solving some really interesting technical issues. And
Right.
and then in 2016, I moved to Galen Robotics, and that
Hmm.
was based on university research again out of Johns Hopkins. And that was a lot of fun because Johns Hopkins, the robot research is currently the director of all of that is Dr. Russell Taylor. He's
Hmm.
considered to be the father of surgical
Yes,
robotics.
exactly.
He was involved at SRI International before Intuitive Surgical was even founded as a company. And so he's really been thinking about all of these technical issues, but also how they're affected by how surgery is done and what's the setup in a surgical environment,
Hmm.
and how much floor space do I have, and what's in the way, right? And so we had this really amazing idea for a robot where you would be holding, and I know we've talked about this before, but
Yeah.
where you'd be holding a surgical instrument and the robot would be holding it with you. And through cooperative control, you would gain stability for the instrument. You would basically improve your dexterity. Depending on kind of the instrument, you could remove some of the weight of it, which improves ergonomics and reduces fatigue for the surgeon. So you had a lot of really interesting benefits, but you also
Hmm.
had some really interesting clinical issues, which were, for example, when you're doing skull-based surgery, let me just give you one quick example. I don't want to gross
Yes.
anybody out, but there are surgeries where you're sticking instruments, including an endoscope, just so you can see up the patient's nostrils, and you're
Hmm.
digging through the front of the skull as well as a bunch of soft tissue so you can get access to the portion of the brain up here. You can
Okay.
only fit so many instruments up somebody's nose.
Exactly. That's
So,
really complicated.
and the smaller the instrument, the less stable it's going to be. If an instrument's extremely tiny in diameter, then the slightest vibration could be affecting, poking a nerve, or cutting a blood vessel, right? So there are so many engineering trade-offs just for, and then how long is that instrument and where is it being held?
Hmm.
And
Exactly.
so all of those issues just really create a lot of just really interesting questions just for one application. And then with this same robot, we wanted to do things like do surgery down a patient's throat, or do middle ear surgery, where the first 90 minutes of middle ear surgery is you're drilling through the hardest bone in the human body, the mastoid, right here behind the ear. And
Okay.
inside the bone are two nerves that cause
Hmm.
pretty significant patient issues if you nick those nerves. And yet, to get through that bone, you've got an 80,000 RPM rotary tool grinding through that bone.
Okay. So we have
And
to drill inside the bone, like.
you're drilling through all of that bone material, and if this 80,000 RPM drill jerks out of your hand, it could actually jerk into a portion of the bone where that's
Hmm.
where the nerve is, right? And now you've just nicked
Right.
the nerve. So the surgeons are holding this drill in just this, white knuckle death grip, like you're on a roller
Right.
coaster, right? And they're doing it to make sure the drill can't jerk out of their hand,
Hmm.
but that's causing hand fatigue. It's
Yeah.
bad for ergonomics. And so, there's all these kinds of areas where it's like, just by holding the instrument with a robot, can we provide these benefits? And that's a great
Hmm.
idea right there. But there's other stuff in the OR. There are surgeons, some of them, the surgeon doing the procedure, the robot can't be in their way.
Right.
And what they were finding, and I love the Da Vinci and I love the whole idea of telerobotics, but for certain areas of the body, it's just not the right solution. And so having,
Yeah.
a big robot and I'm 6 feet away in a remote terminal, it's not there's a lot of reasons why that's just not the optimal solution for skull-based surgery. And so cooperative robotics really did seem to be the best solution there. The surgeon already knows how to do the procedure. They just need the instruments to work reliably with a very flat performance curve. But they've got, a surgical microscope and it's got this big boom and it's hanging in front of their face. So I can't have a
Right.
big robot arm banging into the microscope. So there's all these
Yes.
ergonomic considerations that you really have to feel in. So the moral of this story is when you're designing a robot, if it's surgical robot, or if it's let's stay on the idea of co-robots, it could be a cobot that's doing inventory in a store. Um, um, you really want to be in those environments. You want, as soon as possible, go to one of those environments yourself and
Yes.
actually watch what normal people would see, or try to. In surgery, you probably can't do the surgery yourself.
Exactly.
But if it was an inventory robot, say, okay, show me what the person would be doing that I'm trying to
Right.
automate, and actually
Yes.
think about, really get down to understanding what it is that the function is. Now, on one hand, you may just be taking a very simple, straightforward approach and building an autonomous system that's replacing a human function. Or you may say, you know what, if I've got a robot doing this particular function, I get to do it in such a different way that I can truly optimize it. And here's kind of just an example that just popped in my head. Um, cleaning out sewer gutters and cleaning out drains is
Right.
kind of gross. And sometimes people have to do it. And sometimes,
Yeah.
you've got big city drains and a person can go in there. It's disgusting. There's gases, there's limited oxygen. Sometimes you have to go in there with scuba outfits. You might be able to build a robot that is completely optimized for that environment and can do simply a better job than a human being can, just because you can change the body plan. You can change the way that the robot is shaped. In other cases, there might be, I shop at one of those warehouse stores down the street, and they have an inventory robot, and it's moving around. Now it makes little friendly chirps. It goes wee wee when it sees a person, and I think the reason for that is so that it feels not threatening. It feels friendly. And it's funny. It just goes up and down the halls and it scans and it looks at how much material is on any individual shelf, and it'll report if there's shelf space that's completely empty, because probably it needs replenishment, right?
Exactly.
There, I know I'm going to be working around a human being. Maybe I'm replacing a human being that's doing inventory, but I still have customers shopping. They're walking on the aisles, and so there, my considerations are: I'm working around people. I certainly want to be safe, but I also want to do it in such a way that I feel like I'm okay, right?
Right.
And but if I'm cleaning out sewers and I'm building a solution where the goal is that I don't want human beings to have to go in and climb through all of that stuff, then I can build the robot whatever it can be a giant egg beater, right? And there I have a completely different set of criteria. And so it's really important, engineers, it's real easy. In fact, I was talking to somebody just earlier this week who is an engineer that is so in love with his product and technology that he keeps forgetting that he's got to talk to customers and figure out what they want. And he's all just like, oh, if I had another $1 million, I could do this and I could do this and I could do this. And he's so obsessed with solving his technology solutions that he's forgetting that there are customers out there and they have their own needs too. And he's got to find a way to merge those things.
Right.
So, when you're an engineer, the more you know about that customer solution, the better. And engineers we sometimes have stereotypes applied to us that we're basement dwelling nerds and we don't want to talk to people and we'd rather just and sometimes it's true, I don't know, but it's really important for, if you're working in a new company, when those product managers come in and they try to tell you, I want you to build this, ask them questions, not because you don't believe them, but ask them questions to show interest in, can you tell me more about what the customer is trying to do? Can you tell me more about the customer environment? Because the better you understand, and that's part of the product manager's job. The product manager is that gateway between customer and the product. And then you as the engineer, you're going to get 90% of your information is going to come from the product manager. But you know what? Ask them the good questions, because sometimes product managers get surprised that the engineers want to know this stuff. And so really ask those questions, because you'll find sometimes that you can, with your knowledge and your modern understanding, because especially if you're young and you're fresh out of school, you've learned new things that the product managers might not realize, and the customers certainly may not realize. And this is a common issue when dealing with customers, is the customers will sometimes try to tell you what the technical solution is, and they don't always know it's possible. So it's important to get around that and go, tell me what you're really trying to do. Help me understand what you're experiencing. What are your problems? What do you really want to solve? Don't, and it's great that they're maybe trying to help you out. And sometimes you'll have customers that have engineering degrees, and so they've been thinking about this for a long time, and maybe they've got some really good insight. But really try to get on that other side and get into their shoes and really understand what it is you're trying to solve, and then go crazy. And I think that's the first and most important thing that anybody can do, regardless of what your position is in an engineering group, what level you're at or whatever. But that, in my entire career, I honestly must say that has been the most valuable thing to me. When I look at the most recent robot that I got, through FDA clearance, even during FDA clearance time, we were being asked by the FDA, yeah, but what situation is it for the patients that you're matching this robot to? Tell us more about what the patient condition is. Tell us more about the ergonomics of the OR. So even the FDA is asking us to make sure that we know, so that they know that they're approving a robot for use in an environment, and that we understand that. So, especially in a regulated environment like surgical robotics, there's a good chance that, the FDA in the United States or whatever country is going to ask you those questions, because they're going to want to make sure that you know. So I would say that's the most valuable thing that I've ever learned in my career. And I learned it really early. I had the benefit of working with some CEOs that were obsessed with doing what the customer wanted. To the point where sometimes I thought they were crazy, but it was an ethic that I think was just critical. And looking back on that now, I see that as being so important. I'm working on some other technology that's not surgical robotics, but it actually we're talking to some groups in the Ministry of the Environment in India.
In India,
and I know you're burning your burning season is coming up. And we were told that one of the biggest concerns that you have, kind of on the street in India, is the fields get burned, the soot's in the air, there's the nitrogen dioxide, it makes the red smog, and it's just awful. And what we're being asked is it possible to build technology that could actually filter the air and improve air quality during these periods of time? But then you've got another issue. Okay, let's build a giant filter. Okay, those filters get saturated. Then what? right? You don't want to
Mm,
create another pollution issue by saying,
yeah.
okay, now we've got people that have to drive to all of these giant air filters and change the filters, once a day. All we're doing is creating another pollution
Mm,
issue, right?
yeah.
So can we use robotics to actually automatically change out the filters, deposit them in a collection bin that gets picked up, less frequently? And how do we
Right.
automate air filtration and air quality improvement
Mm,
in a city, or in some of the areas where
mm,
the smoke concentration is bad. Um, and I was in China in 2019 during a really bad smog period for China, and it was awful. I was wearing a mask, and I could still taste the air. And
oh,
so, I've had a firsthand experience with just what that's like, and just the thought of when this customer issue came up, just the thought of me, putting myself in the shoes and thinking like, well, how wonderful would it be for children if I could just clean the air and get that taste? I mean, you would notice it so quickly.
yeah.
If this technology can be deployed successfully, and you could
Right.
just take that ability to taste the air uh, away, you'd notice that overnight. And it's a really cool thing. And again, understanding what that's like, and being able to talk to people and say, what's it like to go outside when the fields are being burned, and just, having that happen. What's the scale of that? You've got some big cities there.
Right. Right.
and
Exactly.
um, and so, what's the scale of an engineering solution required to clean the air in some of those cities, or in some of those dense population areas? And then of course, where my head goes immediately is, because I also think about company operations. So I also immediately start to think, okay, if I scale up a solution like that, ooh, how many people are required to maintain that? And am I
Mm,
creating a human resources problem? Not that I'm happy if we can create jobs, but it's also
yeah.
logistics, right? How do you manage
Mm,
all those people, and how many times a day is that required? And so those are important too. And if you think about, let's go back to medical robotics.
right.
There's a type of robot that dispenses medication.
Like
So
what?
it'll go into like patient.
Hmm.
Yeah, it'll go into like a patient's room, and it'll actually give them their medication.
Okay. Okay. Yeah.
And so
Right.
imagine that, like, who fills the medication? Who makes sure that the programming gets set correctly to know what room you're in? How do you make sure that a patient didn't get moved to another room and it hasn't been updated in the databases? How do you make sure to verify that I'm about to give a potentially lethal drug to the wrong patient, right? How do I
Right.
verify all those things? You got to think about, like, especially any robot that is, I guess philosophically, any robot is ultimately interacting with human beings, as long as human beings
Exactly.
are on the earth. Let's just assume that. Um, uh, who's going to be affected, and how are they going to be
Yeah.
affected? And so,
Right.
even if it's not a cooperatively controlled robot, let's think about those factors. So even just as I'm explaining this stuff to you to answer your question, that's already like popping in my head. I'm thinking about, like, gosh, how you interact with people and how you affect people
Hmm.
with these kinds of engineering solutions. It's it's a it's a great question. If you want to have, your superpower at work, be the person that asks, okay, who's this affecting? Who are the people that are being affected by this technology solution? How do we make sure that it's good? I'm
Right.
not trying to be like, oh, we don't want to take away people's jobs. Sometimes that happens, right? The cotton
Right.
gin, the steam engine. I mean, every major technological innovation in history has affected people, right? So we know that that's
Right.
always going to be there. Um, let's think about it. Let's see how we can really create leverage, um, I guess on the top of my head, personally, I'm okay if no human being ever has to clean out a sewer again in their life. But maybe that's just because
Exactly.
I don't know how people are affected by that. Maybe I don't know. Maybe there's some aspect of that I'm like, oh my gosh, I'm crashing somebody's economy. I don't know. And so you think through that stuff, right? It's
Yeah,
really important.
exactly. Right, right. So, like, it is really important to ask questions, and also the more important part is that to ask the right questions at right time, because sometimes
That's right.
yeah,
Early,
what I,
as early as possible.
exactly, yeah, because sometimes we ask the questions very late, or else we are not able to ask the relevant questions. Like the problem is something else, and we are trying to digging out something different questions. Like we are trying to solve a surgical robot kind of problem. We are trying to ask question related to warehouse robot. So that should not happen. That's what I think.
And that
And
happened. That's happened to
yeah,
me.
exactly. So, like, also your journey into engineering is a kind of inspiring, I must say. Like, you went through all of those kind of technological era from the very beginning till now. Like, you entered into
Mm.
robotics by actually learning a lot of things in the back end. So you have really that kind of experience. But what happens now is that, like, we get a chance to become a robotics engineer at a very early stage, like without experiencing those things. So, what do you think? Like, if you were in this era and you were starting as a robotics engineer, like starting to study robotics, so how will you start? Like, will you take any specialization in bachelor's or focus on self learning or anything like?
Yeah, I know. It's a that's a really good question because there's just so many. There's so many specializations that are each one of them is valuable. I've got a friend who I actually want to introduce you to, and he's an AI
Okay.
specialist, and it's
Yeah.
but his field of AI is about controlling mechatronics.
Okay.
So he's got some understanding of building the robots, but his main focus is how do I use AI to move a robot? And
Hmm.
in some cases, that might be motor motor sequencing so that all my motions are smooth and coordinated. How do I do that in an optimized way? Or dealing with co-robotics, how do I deal with recognizing something around me
Hmm.
and responding to it, like the inventory control robot, right? Um,
Right.
so I think we had a little bit of this discussion last time. It's like, you know, when you're first starting out, you know, get your fingers in as many things as you
Okay.
can.
Hmm.
It's so funny to me how many engineering graduates I've encountered that cannot write a single line of code. And I find it surprising because when I was young, all of the hardware nerds all could they all also knew how to code. And maybe it's just
Right.
because at the time, who else was going to do it? And so I understand that a lot of specialties have gotten so complex on their own that just you've got to split off at some point. But I've got one guy that I'm thinking of in my head. I'm shocked and I'm like, dude, you can't even write a shell script? Really? I mean, this guy functionally cannot write a line of code, and it blows my mind. He's a brilliant mechanical engineer, and so it surprised me. I don't say that you have to, and there's too many things to focus on that you drive yourself crazy trying to specialize in everything. But
Right.
if you're just starting out, I think it's really valuable to get your feet wet with as many things as possible, just so that you know what interests you. Like, um, I've got an Arduino and a little robots kit, and I've sat down with my daughters and we've wired them up. And one of my daughters really loves breadboards. She
Okay.
just, for some reason, she's obsessed with like bending the wires and she loves arranging that stuff. And my other daughter's a little bossy, so she likes coding because she just likes telling computers what to do. And so for some reason, coding just really seems to fit her personality. So I don't know if I should worry about that, but it's funny, but it's a great opportunity to get started and to at least have an idea of what goes into those systems, right? And then as you progress in your academic career, at some point you're going to have to split off and start to, develop some focus. But
Right.
I'll tell you just from my experience at Johns Hopkins, the rock stars always seem to be the hardware nerds that also can code. They
Okay.
always end up with this weird rock star status because, okay, maybe they're not the best hardware engineer and maybe they're not the best coder, but the fact that they're able to like build something over the weekend and then write the code to make the thing, do whatever it's supposed to do, it does give them a certain level of superpower. And
Okay.
at some point, if maybe they become super focused on hardware, they have at least enough coding knowledge that when they talk to the software people, they go, oh, by the way, this is what I need, right? And they can have that conversation and they can have those discussions, right?
Right.
And I think that's where it's critical because it helps you work with the rest of your team, right? It helps you
Yes.
understand their language. Just to divert real quick back to the pollution control technology that I'm also working on. I
Yeah.
have learned how little chemistry I know. Chemistry is a really big universe that I have not probably since 10th grade AP chemistry. So that's where my education stopped in chemistry, and I'm having fun
Okay.
learning about chemistry, but I am reminded every day just how little I understand about chemistry. And I don't
Okay.
expect that I'm going to become some Nobel Prize winning chemist ever. I'm okay with that. but what I do want to learn is I want to understand enough that I can at least be in a room and follow a conversation and go, okay, this is what you're trying. Oh, okay. And then maybe I can take some of those areas of what the chemists are talking about. And then when I go back over to hardware, and some of the hardware that I'm working on is going to be controlled by robotics and AI. So when I'm
Right.
talking to those other groups, I can understand some of the issues over here and I can think about how this new Lego block fits into my overall solution. I at least want to understand enough chemistry to have those conversations to at least understand. I know that those chemists are always going to have something that's going to be way over my head, and I'm okay with that. But I at least want to be able to talk to them, and know my atoms or whatever, right?
Right.
And so I think when you're young, when you're young and you're first starting out in college, it's having that well-rounded education, I think is valuable because it changes the way you see the world. It changes the way you think. I mean, I see this on Facebook and stuff like that. People will be like, oh, why did I ever learn calculus? It's like you learned calculus because it changed the way that you think. I mean, you've got regular math and then you've got math about motion. That is so cool. I mean, even if you forget half the calculus that you ever learned, just the thought that there's math that describes motion of
Yeah.
systems changes the way your brain sees the world. And so, yeah, I don't care if you're liberal arts, learn math. And so it's I think it is really important that you really try to reach out and hey, while you're doing it, maybe learn a little Shakespeare, maybe learn some public speaking,
Exactly.
and learn how to use language effectively because this is what's helped me. I've been a member of Toastmasters International for, wow, I'm great at tangents. I've been a member of Toastmasters International for about 30 years.
Okay.
I was president of a group called Capital One Toastmasters in Washington, D.C. for a few years. And I'll tell you that Toastmasters professionally was probably one of the most valuable investments in myself that
Great.
I've ever focused on. And the reason for that, and I'll tell you, when I first started Toastmasters and I did my first speech, I sounded awful. It was horrible. It was horrible.
First speech is
I'm
always
surprised
horrible.
I'm surprised they
First
ever
speech.
went back. That's right. Your first presentations, you're going to be your worst. And that's why
Yeah,
you do it, right? In
exactly.
photography, I think Ansel Adams used to say your first 10,000 pictures were going to be your worst, so you better get started.
Mhm.
It's the same kind of concept. Toastmasters gives you that environment with other people that want to learn how to be good communicators to go in and give the worst speeches of your life and just keep doing it until you feel comfortable talking and communicating. And communication
Right.
involves listening. One of the things that I used to do, Toastmasters has contests, speech contests. And even though this drove other people in my club completely bananas, I loved having a topic for a speech. And then I would actually go to the contest and I would make up the entire speech on the spot. And I would do it,
Okay.
but I love to go last. And so I would listen to the other speeches in my category. And during my talk, I would actually try to refer to the other speakers and actually incorporate
Mm,
what they had communicated as part of my own speech. And I had first place trophies.
okay.
Do,
Benefit of
making
being
up a
smart.
speech on the spot.
Right.
And but the benefit of that is it forced me to learn how to listen as well
Mm,
as to speak. It's
right.
and I think it's a critical skill. And if you're in a business, if you're in a company, you've got a great idea. You know, you've been listening to product managers, you're reading documentation, and you just have this epiphany, and you're like, "Holy cow! I know how to solve this problem, and I know how to make I know how to make a product that's beyond what the product manager is even asking for, and I need to tell them."
Right.
Right?
Mm,
That's when you need to have the best communication skills possible, because
exactly.
the company might be like, "You're right." And if you don't have that ability to connect to people and to communicate your ideas, they're never going to
Mm,
know. They're never going to
exactly.
know.
Right.
So it's a little of everything. You know, you need to go to the
Mm,
buffet and you need to try a little piece of everything on
right.
your plate, and really, you know, yes, you're going to specialize at some point, but if you're young right now, get your feet wet with a lot of things, because it will change the way you see the world.
Yeah, got it. And like from the like topic that you said about communication, I just popped out one question. Like it's a simple question. Like for example, if a robotics engineer, a technical guy who is having a good technical combination, who is 80% good in his technical skills, and you have a guy who is kind of 40% good in technical stuff, but he has good communication skills, like he can explain well, and yeah, it's good for the team as well. So but like
Yeah,
whom will you hire? Like what do you think about it? Like whom will you hire?
you know, that's a wow, that's a tough one. In my position, okay, so this is one of these weird ones where, you know, uh it kind of changes depending on where you're at, right? So in
Mm,
my position, I probably would end up hiring the one that communicates better, right? Because I'm not the
right.
super expert engineer. So I'm looking for somebody that I can really connect with and go, ah, okay, I see
Mm,
what you're thinking, because now
right.
that's going to be my conduit into the rest of engineering. Now, if I'm like an engineering line manager and I'm looking for engineers to, like, I need you to do this, and I need you to do this, and I need you to do this, that person probably is going to hire somebody that's way more of a, I'm just gonna use this term, the basement dwelling nerd, right? They're going to hire somebody that's a little bit more hyper specialized,
Mm,
probably, right?
right.
And it's just going to depend. Now, and it's funny because I've had this happen, right? I've I've had I've had organizations where the engineers are hiring engineers, and hold on. I've had engineers hiring engineers, and those engineers, man, sometimes I have a really hard time talking to them, but they're doing really specialized work, and I do get to know them, and oh my gosh, they're amazing at what they do. But I talk to them personally, and I'm just like, wow, you are a hot mess. And they're really tough to communicate with them. Like, I mean, there's a couple in my head that I'm thinking about very specifically, and they're just really, really difficult personalities. They're really kind of they're weird, right?
Right.
But I can clearly see how valuable they are. And to their manager's credit, their manager during like status meetings will talk like, this is what this person did, and this is what this person did to contribute. And so their manager is making sure that everybody knows how good of a contributor they are, which is important because it's tough to. And again, I've got some people that I'm thinking of right now, and I'm kind of like almost laughing
Okay.
inside my head because I know that they are excellent engineers. But holy cow, it's like, it's like cracking an ostrich egg trying to talk to them. You're just like, I've got the saw and I've got, a pick and a hammer, and I'm just trying to get through that shell to figure out like, dude, what's inside of you? It's a really tough thing. It in some ways depends on what your career aspirations are. Not everybody's going to be a manager. Not everybody wants to be a manager. Honestly, a person I've worked with, he technically worked for me for about 15 years at one company. And there was a time when there was an opportunity that he could have become a manager because I was going to change to a different position. And he looked at me and he said, I'm not interested. He goes, he was one of the best coders I've ever known in my entire life. And produced more code than any coder in terms of lines of code. But not only did he produce more lines of code than anybody I've ever worked with, he wrote complete documentation. The bug count was the lowest I've ever worked with. I mean, just like everything about him as a coder was amazing. But he was like, I don't have patience for people. And people annoy me too quickly, and then my attitude is just going to be bad. And then the thing that I am good at, I'm not going to enjoy anymore because I'm too focused on things that I don't like to do. And so even though honestly, and we're the same age, so we've got, same amount of gray hair. That's what he does to this day. He is one of the best coders I've ever known in my life, and I've worked with thousands of coders. He is one of the best, if not the best coder I've ever worked with. I would hire him in a second if I had an opportunity that he was a good fit for. But he never wanted to be a manager, and that's fine. But what that also means is he's probably not being hired by a VP level, because typically VPs are hiring director level, right? They're not hiring like the end workers and stuff like that. So it's just gonna depend on what do you really want to do ultimately. There are engineers who I think, in fact, another one I can actually think in my head. There's an engineer, she got her master's degree, and the first thing she said to me is, I don't want to do engineering. What can I do where I'm directly connected to customers? She's personable. She's got a great personality. She's a great communicator. And she realized very early on that she's an excellent, she's an electrical engineer and very good, very competent. And she did some excellent contributions in a previous company in electrical engineering, but she realized herself, I want to be something more along the lines of product management, but I want to be customer facing product management. And so, get a technical degree. I know so many technical product managers that have master's degrees in some engineering field, and then they never do that professionally again in their lives. They become technical product managers and they love it. And that's fantastic too. And so, know thyself, I guess, there's that phrase. From the Matrix, I don't know. When he was getting the cookie, know thyself.
Yeah.
I think it came from somewhere else, but that's important too.
Right.
Not all degrees are things that you're going to use directly to get your job. And think about what you really want to do, big picture, and then how do you get there? And yeah, not every engineering degree results in an engineering job, and that might be fine. That might be exactly what you want, and that's great. And at the same time, not every engineer is going to become the next chief technology officer, vice president of engineering, director level, and that's fine too. Because, and I want to make this super clear from my attitude and the way I see the world, no position is better than any person in any other position. They're about job responsibilities, right? I'm a CTO, and from that standpoint, I have executive responsibilities, and I understand what that means. And I understand of like, I'm doing budgeting, I'm doing forecasting, I'm thinking about buying technologies. Do I have to buy an entire another company? Or do I go out and license technology? Or right now I'm talking to 2 different universities about environmental technologies because I can't invent the chemistry for that. So I'm talking to universities and I'm, okay, who's graduated recently and what companies are they at? And is it a company that I can partner with? Or is it a company that I can buy completely? Or do I hire people myself and do I do that and do I do all that? That's where my responsibilities lie. But you know what? None of that is possible without a team of people also doing incredible work and burying themselves in some of the details that honestly, sometimes I don't entirely understand because I'm not close enough to the actual details of what they're doing. And so even though I'm a CTO and some people think I'm supposed to know everything, that's not my job. It's not my job. And in fact, the more I spend, as much as I love to do it, sometimes if I spend too much time in the weeds, as they call it, really, really overly focused on like specific engineering details, I'm possibly neglecting my job that makes sure that people are getting paid and then I'm creating jobs so that more people can get hired and all that kind of stuff. And so I want to make it really, really clear. Every position is important in a company. And so whatever you decide is a good fit for you, that's a great thing. And just embrace wherever you are. If you're a junior level, be a junior level and learn everything that you can